Hi everyone, you are welcome back to POSTUTME, and in today's video lesson we'll be learning about the topic called expansivity. Now without wasting much time, let's get down into the topic. Now for the purpose of understanding, I have grouped this topic into segments, where the first segment we're talking about linear expansivity, the next we're talking about area and superficial expansivity, the next we're talking about volume or cubic expansivity, followed by apparent expansivity, and lastly, we'll be talking about real expansivity. These are the different parts of this topic you must know. And basically, like I said, we'll be focusing on the calculation aspect on this topic. So what I'll be offering here now is the formulas, and after that, we'll get down straight to questions. So for linear expansivity, symbolized by the symbol alpha. The unit for linear expansivity, that's the unit for alpha, is what? Per Kelvin or per degree Celsius. But in most standard case, it's preferable you use what? Per Kelvin. Now, the formula for linear expansivity alpha is equal to the change in length. This delta L stands for change in length, okay? Over the initial length or the original length times the rise or change in temperature. Whenever you see delta, it stands for what? Change in. So this is change in temperature because theta stands for what? Temperature. So if I was to expand this, I will have this. That is to say, linear expansivity alpha is equal to L2 minus L1. This stands for what? Change. You know, that is the final length minus what? Initial length. All over L1 dot change in temperature will now be expanded as what? Delta 2 minus what? Delta 1. So this and this are the what? Formula for what? Linear expansivity. So without wasting much time, let's get straight to what? Area, also called superficial expansivity. Now the symbol for area of superficial expansivity is beta sign. Now the formula for area of superficial expansivity is the change in area, that is delta A over A1 times change in theta, that is change in temperature. If I was to expand this, I will have this, that is A2 minus A1 representing change in A all over A1 times change in theta, which is expanded to become theta 2 minus what? Theta 1. So like I said, the unit for what? Beta is what? The unit for area expansivity is also what? Per Kelvin or what? Per degree Celsius. So all the expansivity have the same unit to be what? Per Kelvin or what? Per degree Celsius. So straight now we'll be looking at what? Volume or cubic expansivity. Now the symbol for volume or cubic expansivity is the gamma sign, okay, a slanting Y. Now, what is the formula for volume or cubic expansivity? It is the change in volume over the original volume times the change in temperature. As that expanded will give you volume expansivity will now be equal to V2 minus V1 representing change in volume over V1 dot change in theta will now be expanded to become theta 2 minus theta 1. So this is the formula, and the unit for volume expansivity or cubic expansivity is the same as what? Per Kelvin or what? Per degree Celsius. So moving on this way, I gave a number of facts you must note that the area expansivity is twice linear expansivity. That is, if you have a material, let's say iron, and then you are told that the linear expansivity is X, they now ask you what is the area expansivity. It's simply 2 times X because that is a general rule. Okay, all these are general rule. All these things we are seeing here, they are general rule. Whatever is the material, if you are given the what? Linear expansivity, you can get the area expansivity, and you can also get the what? The cubic expansivity. To get the cubic expansivity is 3 times the what? Linear expansivity. That is for any given material, the cubic expansivity is 3 times the what? The linear expansivity. While the area expansivity is what? 2 times the what? The linear expansivity. And the area expansivity is 2 over 3 times the what? The cubic expansivity. While the cubic expansivity is what? 3 over 2 times the what? The area expansivity. All these are the general rules. Sometimes you won't be given area expansivity directly. Sometimes you won't be given linear expansivity directly. All these formula will help you to what? Find your way around question. If you are not given area expansivity directly, what do? Simply times 2 with the what? Linear expansivity that you are given. You will get the area expansivity. That's why they are called general rule. So moving on from there, we're looking at what? Apparent expansivity, what you can call forced actual expansion. It's just part of the actual expansion. So it's the apparent expansivity. The formula for apparent expansivity, and mind the apparent expansivity is symbolized as YA, that is expansivity apparent. YA, the A stands for apparent, the Y stands for what? Expansivity. So the formula for what? Apparent expansivity is what? Volume of fluid or liquid expelled over the volume of liquid remaining times the change in temperature. Volume of liquid expelled, that's why I wrote E, over the volume of liquid remaining, that's why I wrote VR. Dot what? That is times the what change in temperature, which is what? Theta 2 minus theta 1. So this is the formula you use when you're asked a question under apparent expansivity. Lastly, we'll be talking about real expansivity. And real expansivity is symbolized as what? Y arrow, okay? Real expansivity. Real expansivity. And the formula for real expansivity is what? Apparent expansivity added to what? Cubic expansivity of the vessel. Because in real or apparent expansivity, it is assumed that the vessel also expand. So just imagine the fluid inside was to expand like this. Because the vessel expand, it kind of increase in width, let's say in volume. So the liquid will not expand to the actual place, it will reduce because the container is now wider. So it would expand to the, should I say, maximum, instead it will expand minimally. I don't know if you get. So that's why you have the concept of apparent and real expansivity. So if you have calculated the apparent expansivity and you want to get the actual expansivity, it's simply the apparent expansivity you have calculated for the liquid added to the what? Expansivity of the vessel. Because in that case, it is assumed that both the liquid expand and the vessel also what? Expand. So to get the actual expansivity of the liquid, you have to add to get the real expansivity of the liquid, you have to add the apparent expansivity to the what? Expansivity of the vessel. So that will give you the what? Real expansivity. Then I now add lastly that apparent and real expansivity are common cases with what? Relative density bottle. That's the bottle that has the tendency to what? Expand, and the liquid inside will also what? Expand. So in that case, you notice that the liquid inside expand what? Apparently, and the vessel also what? Expand. So to get the real expansivity, add the expansivity of the fluid inside, which is the apparent expansivity, to the what? Expansivity of the what? Vessel itself. So that's why we bring about these two formulas. So now we know all the formulas under the topic called expansivity. I'll be taking one question and let's see how it is being solved. So we take the question now. Alright guys, this is the question we're asked to solve under expansivity. So without wasting time, let's get started. We are going to do this together. Okay, we are basically going to be solving it together. So let's go. They said a metal rod 800 millimeter long. That was the initial length of the metal before it was heated, is it not? So come and write L1 equals what? 800 millimeter. Now you can choose to convert, you can choose not to convert. Why did I choose not to convert? Because the two lengths given was in what? Millimeter. They will cancel out definitely. So I can choose to leave mine as this. Okay? The more you practice question, the more you know when to convert and when not to convert. This is a scenario you don't have to convert because both are in what? Millimeter. So let's continue. Is then heated from what? An initial temperature, theta 1 of what? 10 degrees Celsius to a final temperature, theta 2 of what? 95 degrees Celsius. Then I said, if it expand by. Now this word expand by is talking about the what? The change in length. I hope you know. It's not the final length because they don't say it expand to. They said it expand by. So the change in length is what? 1.36 millimeter. This is the change in length. Then I said, what or find the linear expansivity of the what? Metal. The linear expansivity of the metal is what? Unknown. So alpha is what? Unknown. So now we have initial length, we have the initial temperature, final temperature, we have the change in what? Length, and we have the alpha. That is the question we have to, the one we have to find. Can we solve the question? The answer is what? Yes. What formula we use? Alpha equals to change in length over L1 dot what? Change in theta. This is the formula we are going to use. So observe something. Were we given alpha directly? No, were we given change in length directly? The answer is what? Yes. So simply come and put 1.36 all over. Were we given L1 directly? The answer is Now we now have 1.36 all over what? 800 times, let's do the subtraction. 95 minus 10. The answer is what? 85. Now we have this. We times the guys under. Let's see what we have. We have 1.36 all over. What we now have for the bottom? That is 800 times 85. 800 times 85. What we have is 68000. So now we have this. We'll do the division to get our what? Linear expansivity. So we now say linear expansivity is equals to, let's do this together, 1.36 divided by 68000. So what do we have? We have exactly 2 times 10 raised to our minus 5. What is the unit for linear expansivity? Is what? Per Kelvin. So this is the answer. So the question, I hope you understand how this was done. So about now, I'll be giving you guys your own question, so you can try your hands on. Do it to also let me know what your answer is in the comment section. So let's have the question now. Alright guys, this is the question you are being asked to solve. It reads, a wire 20 meter long, initial length, is heated from a temperature of 5 degrees Celsius to a temperature of what? 55 degrees Celsius. So this is theta 1, this is what? Theta 2. Why this is L1. Then I said, if the change in temperature, you are seeing change in what? Sorry, if the change in length, you are seeing change in length. That stands for what? Theta L, is it not? Is 0.02 meter. Calculate the linear expansivity of the wire. You are being asked to find what? Alpha. So do it to solve this question. Do it to let me know what your answer is in the comment section. Don't forget to share my video with your friend, neighbors and classmates. Thanks for watching. I remain Expansivity. See you in my next video.